So it's good to be back after like 2 years of no conferences. I think all of you are feeling good also. Yeah. So today we are going to talk about data engineering and Python. I don't know, I guess a lot of you work with data, but how many of you know what is sort of like data engineering or work with this day to day, building pipeline stuff? Okay. Okay, so we have a sort of familiar audience right now. So let's start. So I'm just gonna start with this, like data infrastructure. I'm not going into directly data engineering. I'm starting with data infrastructure because that is where the top of the iceberg is. That is why I've put like the entire iceberg there. So that is the start of the things. Data infrastructure, basically it's sort of like everything packed together. So there's a lot to unpack, right? Coming from your ETL to your pipelines, all the things tend together and makes data infrastructure. So in all totality, basically there are a lot of things which are which come together, and these are sort of like your ops, which is now evolving to data ops. There is also pipelining team, which is now sort of getting into analytics engineering. And there's obviously like data engineering in the sense of ETL pipelines. So these are the main or sort of like the fundamental things that comes into data infrastructure. The main goal of data infrastructure inside in any organization is to basically get data moving. It could be from one source to another source, and these different sources or destinations are basically used to serve different purposes. One source is serving one team, and that team has sort of different objectives, and wherever you're moving your data from that source to another system, that system would be maintained by another team which has different objectives, right? So that was data infrastructure. Now I'll introduce myself. I am Prakhar. I'm building data platform for TicketSwap. It's a basically marketplace for reselling tickets. So we are basically reselling all your events and concert tickets, and I'm building like data infrastructure there from ground up. So that is interesting. By the way, you can find me anywhere on the internet with the handle Prakhar code, so it works. And there's also my website. So that's my socials. Okay, why are we here? It's like, why are we here? Basically, we are discovering, we would be discovering throughout these talks to help of demos and everything, how is ETL sort of evolving, what are different types of ETL that exist, and why what is the entire infrastructure evolving into. That is one thing that we would be discussing here. And obviously, at the end, I would be giving some tips for people who want to get into data engineering. Quite a new field, but I think it's catching up a lot. Sort of, I think, becoming the new data science of Python ecosystem. Okay. So the agenda is plainly simple. We would be discussing like what role data engineering plays inside an organization, and then some ETL concepts. I would be demoing batch and streaming pipelines, and then would be talking about in the same sense why would be needing real-time streaming analytics, and then obviously how to get started in data engineering. So yep. Again, data engineering. So crux of this is to get data from one source to another destination. These, again, serve different purposes. The main job for an data engineer is to create ETL pipelines. I'm saying main job because that is how it evolved. Now it plays a lot more different roles. There is also data governance and analytics engineering, and we can get deeper into that. But the entire scene for data engineering is to create ETL pipelines, and these transformations can be very simple, can be from one group by two. I think also your machine learning models are transformations in the sense you map one domain to another domain. So that is also one sort of transformation. So it encompasses all sort of things that you do with data inside an organization. But then the question comes, why do we need an entire infra for managing data? Like, if you want to do analytics, can't you just simply plug into your production databases and do your reporting and stuff like that? But no, we need data infrastructure basically to handle data at scale. In small organizations, it's easier to build up pipelines, or you can just copy data from one schema to another schema. Wouldn't recommend that, but when you have to get things done, you can do that. But then again, there are multiple technological constraints. Could be your database is not sufficient enough for sort of analytics that you want to do. You want to move it to another database which has some greater optimization for running different sort of queries. Then for your business teams, it could be very different needs from your entire team or entire infrastructure. It could be based on reporting, it could be based on fraud, it could be based on different sort of needs that your business requires, right? Okay, and then also there's a multifunctional team with specific needs. The end user could be another team which is building machine learning models. That could be one user of the entire data infrastructure. Another consumer could be your business team, which would be looking into frauds, which would be looking into where they can grow the business. That is where also right now growth analytics is coming into. Like if you're doing a lot of ad campaigns, how can you get all that data and combine it in a sense that it is useful for your growth team to specifically target different areas, right? And then obviously this all combines into data-driven decisions. Like at the end, we get into basically to speak, what can my data show? That is what the entire need of an infrastructure is. So what does an eventual data system looks like? Basically, there are different sort of implementations, but the main crux of the system remains the same. There's one source, multiple sources, and there are multiple destinations. And then there's one like data infra, which is responsible for getting data from this source to the other destination. How it can be done? It can be done in real-time fashion, and it can be done in batch fashion. People opt for both right now. That is sort of like Lambda architecture, but in a newer sense, we are getting into another sort of architecture where everything is event-driven, sort of getting into Kappa architecture, where everything is real-time stream or near real-time stream, right? So let's start. This is the images of a Lambda system, wherein one is your batch layer. Batch layer is basically when you take data from your source in a set of batches, and these batches could be time-driven, could be business-driven. Like logic could be business-driven, could be time-driven, could be any sort of metric that you want your batches to be on. This could be like number of rows driven, and real-time is just plain simple. As soon as you get your data into your source, you want it in your destination. So real-time layer is mostly used for fraud systems, and where your business is dependent on time. Like if you are Amazon and if you want to buy a lot of, if you want to keep filling your inventory, you need to know when is your inventory going to get over, and that is where, like, if you scale it up, seconds count, because you need to keep on fulfilling your demands of the customer, and that is where real-time analytics come to play. Batch layer is sort of like when you need to relax, chill, and you can wait for your data, you can wait for its certain time, and then you can do analytics over it. It could be like for training of your machine learning models, right? So these are all the terms that are usually related with data engineering. You can take a picture. I won't be getting into deeper into these, but like OLAP or OLTP, these are like sort of different databases or architecture inside databases in which you can, there are different types of optimization for particular queries. ETL again, ETL would be something that we would be discussing deeper. Data warehouse is basically the holy grail destination. Wherever your source is, data warehouse is your sort of destination. Right now, people are getting into data lakes and data mesh, also like delta lakes. I'll keep on throwing these terms, and you can ask me in the question answers, or you can reach out to me. But this is sort of like the primer, and we can discuss it later on. But right now, we are just introducing data engineering as whole. Again, I went through Lambda versus Kappa, so this is fairly clear. If you are using real-time plus batch systems, you are in a land, sorry. And if you are using sort of your only stream analytics, you are in a Kappa sort of situation. Okay, something interesting, like we would be getting into demos now. So what and why is ETL? ETL basically stands for extract, transform, and load. It literally describes the process. I don't need to get into like deep into it. It's basically extracting your data from a source, transforming it, and loading into your destination. But these transformation could be anything, and could be multiple. So it could be ET, TTT, L, and stuff like that. So, okay. So there are two types of ETL currently. Broadly, batch and stream. Batch is already I told you about. So it's sort of like taking your data in small sets of pieces. These pieces could be divided into any logical differentiation that you want. It could be based on time, based on size, based on process. Maybe you want to have some different process at a given moment in your business, and then you do your batching according to this. So I have a demo. It's based on Celery, and also this is. I don't know if I can get it bigger. Yeah. So basically, the demo would be like, there would be one file from the user, and I would be using Celery in a sort of like Airflow-like manner to get data from one destination which is local to the database, which is Postgres here. So if you have studied like Airflow, or you know about Airflow, Airflow was developed with some sort of this architecture, where there's a messaging queue, and there are multiple Celery workers, and they are running in parallel to serve different tasks. And here, each of the Celery worker would be different batch. That is how I'm going to execute the demo. I would be just executing it, and then I can share the source code so that you can go through the code. So we have like different systems, or like different components here. I think I turned on the wrong demo. My bad. So we have different components here. One is RabbitMQ. Then there's Flower, which is like central manager for Celery. Basically gives you the view of what all tasks are going on. There's Postgres. Grafana and Prometheus are basically to monitor and manage stuff, not like basically what is going on in your current entire system. and then there are like 2 workers. These workers would be directly executing whatever ETL is going on, and then there is like one metric page which gets all the metrics from the entire system. So oh, it's just like I'm executing a script. So it's basically an it's basically an app which is like the front layer of the entire system, and you can just say to execute data, like ingest data, and it will break it into chunks, and these are like different chunks, and it so there's one CSV, it breaks into different chunks. Each chunk is given to a celery worker, and it takes on turns. So basically we have 2 celery workers, and there are like, I guess there are 78 different chunks which are generated, and they take turns into processing them and feeding into the Postgres system. So right now we had the data sitting in this dump. It already, so we had this CSV, and it already broke it into different 76 pieces, and then fed it into our it fed it into this table. So what happened is this entire infra why I had created is it was a small project in which I wanted to see if we have a file which is, let's say, 500 GB of CSV in size, and if you want to load it into your locally in your local data or anywhere like in any database, can you break up into different tasks and load it parallelly? So this is what happens when I say in this particular script, it takes the CSV, it makes chunks, and it starts submitting into queue, and then from the queue, worker picks up the task, reads the data, get the chunk from the data, and feeds into Postgres. There's also a couple of logic of deduplication, which is where your transformation comes in. But I think when I'll share the scripts, it would be pretty clear. Like it's just SQL transformations based on like dedupes. So this is one demo, and if you like pay attention, like this, the rabbit, like from RabbitMQ to the celery worker, if you put a box over it and name it Airflow, it's the same thing that Airflow does. So you are submitting tasks to a messaging queue. In like if you're submitting a DAG to Airflow, it's basically breaking each task into into different definitions and feeding it inside a queue, and then scheduler. It's basically scheduler, and then basically all the Airflow workers pick these tasks according to certain sets of rules. Okay, this was a batch demo. Now we get into streaming. So batch is sort of easy because it's straightforward. I think most of us are, grown into data in sort of batch fashion. Everything, like if you're a machine learning engineer, you are also doing like batch processing and everything. So batch comes fairly easy to us. When it becomes difficult when we turn to streaming. So mostly streaming is used in situations where each and every second counts, and your analytics need to be in near real-time fashion. Something like fraud is a very good example. Like you want it to be discovering new patterns as soon as the data comes in. You want to figure out whether a transaction is fraud, and this should be in real time. And I think this is one good example of streaming. streaming is basically as soon as the data row comes into your database at source, you need to extract, transform, and load it to your destination at that moment. So I'll get into another demo. This demo will be like showing the real power of streaming analytics right now. And it's basically based on Debezium plus Kafka. So this is not like a fairly closed Pythonic system, but I still want to show it because this is like the main power of analytics, like streaming analytics. So I can show you. Oh, okay. Just make it again. So what happened is currently we have the system wherein there's a source which is a MySQL. There's a destination database that is Postgres, and then there is Kafka, and another would be Kafka Connect. I won't be getting into Kafka, but it's basically streaming queue, wherein it's not a messaging queue; it's entire streaming platform, but it is basically getting your messages in a sort of topic fashion, in which you can there are multiple producers, multiple consumers. Producers can generate different messages, and consumer can choose what to select from the stream. So I'll just register a sync connector. Source. So we have our source and sync on. So this right now there's nothing in the dashboard, and you are not able to see any sort of analytics going on. I'll just start a script which would be feeding random numbers to our MySQL database, and then at the same time you would be able to see the analytics that are driving from Postgres. So this is inserting data right now, random data, X, Y coordinates, and I think you can see in real time there's system is upgrading. So you can imagine, like, if you want to create a system which has sort of streaming and analytics, you can get the data in your source database, and meanwhile you can transform and show it however you want to your end users. I think we are just nearing the time, so I would be closing this up with the final slide. So data engineering and it's as I've showed in the demos also, it's not just Pythonic system. This is compilation of different systems, and I think there is no silver bullet when it comes to your needs of different team to serve them. There are multitudes of data systems that are evolving right now. There are different sort of regimes which are being formed, and there are different methods and sort of different sort of data engineering practices that are being evolved right now as we are studying about it. It's the same for any evolving field. It's going very fast. One thing that I would like to say is like whenever you are thinking of trying to make a data system, I think you don't need to think like you are creating some snippet or a library. I think whenever you're creating a data system, it should always be sort of like where you should think of it as you're creating a data system. If you're thinking it like that, you can make scalable choices. And libraries don't go far. Systems can evolve to a bigger system, right? And these are a couple of tools or some couple advices that I want to give out to everyone if they are going to start into data engineering. I think there are a couple of people who have already started, but I think for instance, you should learn like Airflow. There should be one experience with like any messaging queue. I think Kafka is getting pretty deep into streaming analytics. So if you want to get into streaming analytics, you need to know about Kafka. And obviously, good system design or software design is key to any data engineering decision. Like whether if you're a small or like you're just starting into data engineering or you're like leading a team, if you don't know how to build scalable systems, it will not last. And again, like end-to-end development mindset. So your one decision how it can scale to cater a lot of needs is what our data engineer needs to think when he's taking or she is taking a decision. That is about it. I think I exceeded the time, but thank you everyone for listening. Yep.
Thank you for the talk. And we have one question.
Yep.
Okay, the question is, suppose the data you want to send a task like training ML models, how do you manage synchronization?
There are a couple of things when it comes to synchronization in batch systems. Also streaming systems, basically you can put one more task which evaluates whether all the tasks are complete or not. So this is how Airflow also manages. You can run a particular task if all the tasks before it are completed. So I can show.
We have just 1 minute left. Just 1 minute left.
Okay. Wait. So imagine like if these two tasks are dependent on the third task, you can just place a condition whenever this task is done, only then pick up the task from this queue. So that is how you can make contingent tasks, basically. And that is how also Airflow manages. Like you on each task, you can put on a condition if X number of tasks are done, and only then execute this particular task. And imagine this task to be a machine learning model. Then you can do all sort of transformation before feeding data into your model directly.
Okay, thank you.
Yeah.
Thank you very much.